In this problem, we're graphing asymptotes of rational functions. In the first of the two questions, we are to graph the horizontal asymptote, and down below in this field, write its equation. Before I actually show you the shortcut rules for finding horizontal asymptotes, just look at the graph and let me explain that the horizontal asymptote here turns out to be y equals 0, which is the x-axis. What this means is that the graph down here is getting higher and higher and higher as I trace to the left. We'll get as close to 0 as possible but never cross. If you extended the graph going to the right, it would get lower and lower and lower and never actually hit y equals 0, just get really close. To know this, there's some shortcut rules that you're supposed to know. Here's the summary of the shortcut rules. It gets a bit wordy. For example, what you do to find a horizontal asymptote is you compare the degree of the expression in the numerator. In this case, the expression in the numerator is the number 3. And then you compare that to the degree of the expression in the denominator. The expression itself in the denominator is x minus 2. If you remember, the degree is the highest exponent of that expression. So I'm going to show you this in a second. But because it gets really wordy and difficult to remember, what I give my students is a short list. Instead of saying the degree of the expression in the numerator, I use the letter t. T stands for the word top because a lot of people call the numerator of a fraction the top. Just remember that t isn't just the expression on top, it's the degree of the expression on top. So, for example, in my case, the top of the fraction is the number 3. A polynomial that's just a constant with no variable is known to be degree 0. So by my notation, the degree on top is 0, t equals 0. Now I need to compare that with the degree on the bottom. The expression on the bottom is x minus 2, but what I want is the degree of that expression, which is the highest exponent. The highest exponent here is 1 because x is being raised to the first power. So my bottom, I'm going to call b, is 1. So remember that what I mean by bottom is the degree of the expression in the bottom. So I have the top is 0, the bottom is 1. Since 0 is less than 1, I have a case where the degree on top was smaller than the degree on the bottom. So when you have this, top is less than the bottom, looking at my shortcut rules, we have this second case right here. If the top is less than the bottom, you always get y equals 0 as the equation for the horizontal asymptote. So I'm going to go back here, I'm going to type in y equals 0 as the equation in the field below. And I'm also asked to graph that line by using this draw command here. What you do is you click on the command, and now we have to draw a horizontal line. They go left and right through y equals 0, which is basically the x-axis. So pick any point on the x-axis, click and hold your mouse button down, drag either to the right or the left, make sure it looks horizontal, pick any other point on the line y equals 0 and let go of the mouse key or button, and you basically get the line y equals 0. So this is that line that I was talking about that the graph will get infinitely close to if you go way to the left and way to the right, but it actually never crosses. The second problem has us finding the equation for a vertical asymptote, which is completely different. So going back to my rules here, and by the way, I'll do videos in the future showing perhaps what these other conditions look like. Let me scroll down to the vertical asymptote rule. The rule for finding vertical asymptote, not really a rule, but procedure, to find the equation for a vertical asymptote, which basically is a vertical line, what you do is you set the denominator equal to 0 and solve. My denominator on the second part, since it's the same equation as before, is x minus 2. Before I actually show you the procedure, which is really easy, you can actually see in the graph that it's about x equals 2. Remember, a vertical asymptote is where, not where the graph goes horizontal, but where the graph looks vertical. So in this case, even though we have the same graph, we're concerned where the graph goes vertical, which is right here. The graph gets really steep right here, near x equals 2, and very steep up here. It's hard to tell exactly where, it turns out it's x equals 2, but between 1 and 3, exactly where the wall is. I like to call it a wall that the graph doesn't cross, but basically approaches. So basically what you do is you take your denominator, x minus 2, you write it down, set it equal to 0, and solve. Now this is wrong. We solve it by adding 2 to both sides of the equation. If I added 2 to the left-hand side, you'd get x. If I added 2 to the right-hand side, you'd have 0 plus 2 is 2. So basically with this equation, x equals 2. But it's actually the equation for a line that we call the vertical asymptote. And so we go back here and we type that in. The vertical asymptote is x equals 2. At least that's its equation. Now when I draw it, it'll be a vertical line through 2. So I'll pick any point on this vertical line through 2, click and hold down. Now this is a redo of my last video. In the last video I had it slightly to the right. I can't even reproduce what I did. It was so close. So this is basically the right answer, but in case you're like me and you make a mistake, what you can do is you can hit clear all and start over. So somehow what I had done is drawn a line that was just a little bit off, and it seems difficult to reproduce it now, but you won't get the correct answer if it's not perfect. So this is a perfect vertical line through 2. So what I did there was just pick a point, hold the mouse button down, pick a second point on that vertical line, and let go of the mouse key, or mouse button that is, and simply let go.